on bonding. So I'd like to just remind you how many types of bonding there are up to KS5 levels. This video is for KS5 post 16 caliber. So I'd like to start off with the broad values. The first one is coulombic in nature, which is the electrovalent bonding, which is known as the ionic bonding. It's between polar opposites, group 1, group 7, group 2, group 6, group 3, group 5, and and then the second one is covalent bonding. It's between non-metals. So the first one is between metal and non-metals. The second one is only between non-polar elements, which are the non-metals. So chlorine, oxygen, chlorine, fluorine, and all of that. So, and then the third one we've got is metallic bonding. It's between metals, transition metals. The D block. D block, dx squared minus y squared, dz squared, subscript. So, and then we've got dative covalent bonding, which is quite interesting, which is also known as the sacrificial version of covalent bonding, where one element cooperates a little bit more than the usual. So, examples like carbon monoxide, carbon dioxide, and a few others are. It's a bit rarer, but nonetheless, it's out there. So these are the four, and then we've got the giant macromolecular structural covalent bonding. Now, these are the regular versions of bonding. However, we need to take a look at what's out there apart from this. We've got phenomena like hydrogen bonding. We also have a force called Van der Waal forces. We've got London dispersion forces. Pole-dipole interaction. And then we've got colligated properties like adhesion, cohesion, cohesion, capillary action, and I think I'm forgetting a few. So there's hydrogen bonding, Van der Waal forces, London dispersion forces, pole-dipole interaction, adhesion, cohesion, capillary action, and I think that's about it. So we've got the major bonding forces, and then we've got the weaker bonding forces. The weaker ones, they operate at intra-atomic, intramolecular level, whereas these ones, they operate at interatomic, intermolecular level. And hydrogen bonding is between water molecules. Van der Waal forces are between different kinds of compounds, such as non-polar solvents. London dispersion forces, they are also weakly available amongst a variety of compounds. And then you've got the pole-dipole interactions in aqueous ionic solutions. You've got adhesion, cohesion, and capillary action in water. So this is how it is. We start off from ionic, which is coulombic in nature, and then we go to covalent for non-polar materials, then metallic bonding, dative covalent bonding, giant molecular covalent bonding, which is a characteristic of concrete, and silicon dioxide. And then we move on to hydrogen bonding, Van der Waal forces, London dispersion forces, pole-dipole interactions, adhesion, cohesion, and capillary action. So I hope this helps you to get a pedagogical understanding of A2 post 16 bonding chapter of chemistry. Thank you very much. Cheers, bye now.